Okay, good morning. So we're going to work on 5.6, which is all about exponential depreciation. So when you buy an item, same with like when we talked about like buying a washer and dryer, or buying a refrigerator, buying a car. So it does exponential depreciation. So the depreciation, it goes down. This would be the first. Okay, so essential question, everybody, how can you calculate the depreciation of a car? Okay, so what we're talking about, everybody, with this is that for items, so the values decrease the same percent each year. Okay, and it's called exponential decay. Okay, so let me if I spell this right. Exponential decay. Okay, so our formula is y is equal to a 1 minus the rate raised to the x. Okay, so just to get kind of some things for you to figure out with this. So y is the used value, so the depreciated value. A is the starting value. So it could be the value, say if you bought a used car, okay, it could be that value or the value when it's new. Okay, and then we're going to be using this table. So age is our x value. Okay, so of course we have our rate. Put it over here. So rate is the percent of depreciation. And then x is the elapsed time in years. So the time that is passed. Okay, so we have this. So this is the percent. Okay, that's the rate. Okay. And this whole thing is a formula that we are going to be using. Okay. So if you notice with this, so let's look at an example for a car. So like the first year, it's at 24,000. By 10 years, the value is depreciated to 11,525. Okay. So let's do an example with this. So we have the original price. All right, let's do another example. So actually, instead of original price, let's just do the used price. We're just going to do a regular one. So, okay, so we have that Corey. But a 5-year-old car. which originally sold for $25,000. It depreciates at the 9.2% rate. And we want to know what is its current value. Okay, so we're going to plug that in that formula, everybody. So we're going to do y is equal to, okay, the 25,000, everybody, is our A value. Okay, and then it's going to be 1. Purple one. So you couldn't see this at all. Okay. So 1 plus the rate is a decimal, so 0.0292 raised to x. Okay. Remember, x is the age or the time. Okay. Okay, so we're going to plug that in the calculator. So we get y is equal to, so the car depreciated to a value of $15,430.12. Okay, so our next one, so what if we're looking at, we want to get the original price, okay? So if we want to solve for A, okay, so we're going to take our formula, and I'm going to divide by 1 minus the rate raised to the x. Okay, that's going to cross out and become 1. Okay, so now we have to find the original price. It's going to be y is equal to 1 minus the rate over x. Okay, so let's do an example using this table, everybody. Okay, so we have that the age is 7. The y value is $14,075. Okay, so we're going to substitute that in. Okay, and our rate is 8%. Okay, so we're going to plug all that back into this equation. Okay, so we're going to do the 14,075. So with these, everybody be really careful and read the questions carefully so you know what you're solving for. And then, so you know which equation to use. And then 1 minus, remember, drop the percent sign, go to the left, the decimal and the 0, or divide by 100. Okay, x is our 7. So we're going to put that on the calculator. And we get A is equal to $25,230.95. Okay, so that would be the original price. Okay, what if we needed to find the depreciation rate? Okay, so if we're looking at this, okay, let's say we have, so we have for Herman, Bought a 4-year-old car. For $16,400 when it was new. It cost $23,000. Okay. And we need to find the depreciation rate. Depreciation rate. There we go. Okay. Okay, so we're gonna have, so the formula for this, everybody. So as you can see, this is the one for original price. Okay. Okay, so for the rate, it's going to be, the rate is equal to 1 minus the used price divided by the new price raised to the 1 over x, okay, times 100, and that will give us, everybody, the percent. Okay, so let's do our example, everybody. So used car, okay, so 4 years, so that's going to be our x. Used, when it was new, it cost $23,000, so that is going to be our A value. Okay, so we're going to substitute those all in. So we're going to have the rate is equal to 1 minus 16,400 divided by 23,000 raised to the 1/4. Okay, and then we multiply that by 100. We're going to round to 2 decimal places. So I get 8 and 11/100. Okay, so make sure, everybody, that you're rounding to 2 decimal places on these. Okay, so let's do a new example, everybody. Let's say we needed to solve for time, okay, because we can also solve for time, everybody. Oh, I can put 11. Okay, last one. Okay, solve for time. Okay, so the formula for this is it's ln over y divided by a, okay, and then over the ln of 1 minus the rate as a decimal, okay. Remember, this is used, y is used, a is new or starting, because it could also be the amount from when you, if you buy a used car, it could be that amount too. Okay, so let's figure out, so how long would it take? So let's say we have a new car. It's 21,000. It depreciates at 4.95% to 18,500. How long did it take? Okay, how long did it take to depreciate to 18,400? Okay, so we're going to go ahead and plug those in. So this is our new values is 21,000. Y is our used value. Okay, and then we're going to do the rate as a decimal. So we're going to have x is equal to ln, and then we're going to have the 18,500 divided by 21,000 all over the rate, and then 1 minus the rate is a decimal, so 0.0495. Okay. Remember for time that we round to the first decimal place, to one decimal place. So we round to the tenths place, or I call it the dimes place. So it will be 2 and 5/10 years, so 2.5 years. Okay, it takes to depreciate to that rate. Okay, everybody, you got this.